Good morning, Group A. Today is the 22nd of January. And what we're going to do today, or your title for today, is expansion and contraction. Now, you should be familiar with these words because we used them last lesson. One of them means getting bigger and one means getting smaller. Can you remember which one is which? So what we're going to do today is we're going to have a quick look at last week's prep, just to have a quick look at your answers and what you wrote. Then I'm going to look at quite a lot of you are sending me pictures of your work, which is great, but your pictures, or the pictures you send, are very, very difficult to read. So I'm just going to ask you to change. I'm going to show you how I would like your pictures to be sent. And then finally, you're going to do 2 investigations, today or over the weekend. But if you can't, it is fine. I would just like you to watch the videos and to listen very carefully what is happening in each of the investigations. So let's get started. Now, in last week's prep, we were looking at changing temperature. We were looking at changing temperature. Okay, and we were looking at why things were changing temperature. So here we've got someone walking. We said it's got a bowl of very hot water. So inside here there is very hot water. If we say very hot, you know, anything from about 70 degrees Celsius is probably very hot. So she takes the bowl and then she leaves it left in a room where the surrounding temperature is 20 degrees Celsius, which means the room is 20 degrees Celsius. And we spoke about this last week. We said what's going to happen is that this is cold in comparison to this, and this is hot. So what's going to happen is the temperature is going to decrease. It's going to become less. Okay? The temperature is going to decrease. So after, let's say, an hour, it will not be 70 degrees anymore. It might be 60 degrees, or it might be 50 degrees. If we leave it for a very, very long time, degrees Celsius, for a very long time, like for example, if we leave it for 5 hours, what will happen is this temperature will decrease until it reaches the temperature of its surroundings. Okay, so after 5 hours, the temperature of the room is 20, the surroundings is 20, which means the bowl of water is going to go to 20 degrees Celsius. So I'm sure you all wrote that. Now, question 2, there's no picture, so I'm hoping someone helped you with the reading. It says here, if we left a bowl of cold water in the same room, okay, so instead of hot, this was cold. Let's do a different color. This was cold instead of hot. So cold might be what? 4 degrees Celsius. Okay, and this same bowl is taken to this room. We will find that if we compare some of the temperatures, okay, if this bowl is 4 degrees Celsius and the room is 20, this water is going to get hotter. Okay, and then after a few hours, we'll find that, let's say after 10 hours, the bowl of cold water, which is 4 degrees Celsius or something similar, will increase to 20 degrees Celsius. Okay, alright, so the next couple of questions are exactly the same. We have some cake. Okay, we've got some cake taken from a hot oven. This is an oven. And after 10 hours, what will be the temperature of the oven? Sorry, of the cake once it's taken out of the oven? We can see that it will be 20 degrees Celsius because the room, the surroundings, is 20 degrees Celsius. A cup of hot tea left after 10 hours. Okay, the tea is hot, the room is 20, it will get colder, and after 10 hours, it too will be 20 degrees Celsius. If I take some frozen peas, but I'm sure you know what peas are, we take it out of the freezer. It's probably started at this temperature, minus 15 or thereabouts. And if we leave it in the same room for 10 hours, okay, for 10 hours or for a very long time, it too will have the temperature of the room. The room is 20 degrees Celsius, so it too will go to 20 degrees Celsius. Last one. Okay, so we're going to look a little bit more at expanding and contracting. Now, expanding means if something gets bigger when we make it hot. Okay, and contracting means something that becomes smaller when we make it cold. So this one is expand, expansion. Maybe a bit tricky to figure out. Now, some of you said on this one said contract, and I assume you said contract because this one was expand, but actually it is not contract. It too is expand. Last week's prep, I would like us to have a quick look at how you need to submit your work. Okay, now, if you submit your work like this to me, what I do is I check your work. So I say edit post, okay. And now the problem is that it is quite small. Now I can go closer, but the problem is then you will struggle to read it. You have to then go in, and then it's quite difficult to read. It is hard for me to read this. This is from one of my senior students who submitted their maths work, and it's quite difficult for me to read. I mean, especially that I can't read what she wrote here. I can't read that. So what I would like you to do instead of sending me a picture of your whole page, send me a picture maybe of half a page. Okay, so send me half a page, send me this instead of your whole page. So maybe just send me this and send me 1, 2 pictures or 3, 4, because you can always add pages, you can always add. So I've added a page here, and you can see this is much easier for me to check. I can now quite easily go and I can do that, and I can do that. I can read this very, very clearly, and when I finish with the work, or when I'm finished with the work, okay, it is a lot easier for you also to see my responses. Okay, you can see if you've got it correct or whether you've got it wrong. It's a little bit easier, especially when we click on it and it opens like that. It's a lot easier to read than this. This you won't be able to read. Okay, so please make sure we do that. Alright, let's get started. Let's get started on our 2 investigations. So, 2 investigations today. Investigation 1, okay, we are going to show that air expands when heated. So when we make air hot, it expands, and we're going to show that air contracts when cools. When we cool it down, air contracts, it becomes smaller. The second investigation is you're going to make your own thermometer. And by doing this, you're going to show that water can also expand and contract. Water can also expand and contract. Alright, let's start with investigation 1. This is the easiest one to do, and it is nice and quick. Now, you will need a balloon, a bowl, a plastic bottle. Now, the smaller the bottle, the better. Okay, I use bottles this size, and it worked, but not as effectively, but it did work. So it's fine if you've got a plastic Coke bottle, but anything bigger than a 2 litre or 1 litre bottle is too big. So preferably use a smaller one. You'll also need a kettle. Now, because we're going to use hot water, you can't do this by yourself. You need mum or dad to help you with it. So please, some adult supervision. You're going to need some ice. Okay. So step 1 is you need to place a balloon over the mouth of the plastic bottle. So this balloon needs to go over the mouth of the plastic bottle. Like this. Okay, and you can push the balloon in a little bit if you want. Step 2. Place the bottle in the bowl and start boiling a kettle. So put your bottle inside the bowl if you want, okay, and then you need to boil the kettle. Once the kettle has boiled, what you need to do is you need to pour the boiling water into the bowl, and what you should then see is that the balloon will inflate. Once you've done that, you can remove it from the hot water, and you can have another bowl with ice water in it, and you can put that bottle in the ice water. Let's watch a quick video just to see how this is done, and then we'll go back, or we'll move on to the thermometer, making a thermometer. This video will demonstrate what you need to do. We are going to look at something called expansion and contraction, and here are some of the things that you need. So we're going to start off by taking a plastic bottle, and you can see the plastic bottle's got the balloon over the top of it. One bowl has ice water in it, and the other bowl we are going to put boiling water or hot water in it. So please be very careful, make sure that mum and dad are helping you with this. So boil a kettle, and I'm going to put hot water into one bowl, boiling water. And then what we're going to do is we're going to take the plastic bottle with the balloon over the top, and we are going to insert it into the hot water. And the air inside the bottle will expand, gets bigger, and the balloon inflates. Now what we're going to do is we're going to transfer the plastic bottle into the ice cold water. Okay, you can see how the balloon is inflated. It's quite effective. Put it in the ice cold water, and immediately we'll see the balloon deflate because the air inside the bottle contracts. Now I'd like you to try this experiment either today or over the weekend, and I would like you to take a video using your tablet, and you can send it to me in Seesaw. Okay, thank you. Alright, so investigation 2, making a thermometer. Again, parents will need to help you with this. We'll need the same equipment we did last lesson, but this time we will also need, please make sure you keep the lid, because you will need the lid. Okay, you're going to need a straw. You're going to need a pen to make some markings on the straw. Okay, and also, now something which I've not included is you need to make a hole in the plastic lid. Okay, you need to ask mum or dad to do that, and they can use any sharp piece of equipment. Just got to be very careful, make a hole in it. The straw needs to go through the cap of the plastic bottle. Now, if you don't have some of these things, if you don't have a Sharpie, you don't need it. But you do need a straw, you do need a plastic bottle, you need a lid, you need a kettle, you need some bowls, you need some ice. If you don't have any of this, this is putty, the sort of material that children play with. Okay, if you don't have that, you can improvise a little bit, okay, on all those things. So for example, I did not have any of this, and I did not have food coloring. So what I did was, now the idea behind the putty is that it seals the straw on the lid, so the air can't come out. So that's what it's used for. But what I did was, I used a glue gun, a hot glue gun. If mum or dad has one of these, then they can use that if they like. And I obtained something. As long as the air can't come out, then that's fine. I didn't have food coloring, so what I used was, I used some watercolor paint just to change the color of the water. And I got something like that. Alright, so again, let's watch a video to see how it's done, and then I'd like you to go away and see if you can do either investigation 1 or 2, or you can do both. And there will be some stars awarded to students who complete investigations and who submit their work.
need to put the cap back on, and I have a problem. I have to increase the water level in my straw. I could do this a couple different ways. I could have a food dropper or an eyedropper and add water to the straw, or I could use a different technique, and I like this technique. All I'm going to do is blow into the straw just really gently. You'll see air bubbles come up, and it'll raise the water level in the straw. Check this out. And what do you know? So I made up my own little thermometer.
I ask you to submit your videos and pictures. So take some videos and pictures of the balloon inflating and contracting. You can take pictures if you like. You can label the pictures. And please send that to me. Submit your videos and images in Seesaw. And you can submit more than one. So it's not, doesn't have to be just one. You can do a couple of pictures and a video if you like. And you can do this either on Friday or over the weekend. And if I could have it by Monday, please.